The Technology Pull-Through programme is one of the ways in which we engage with academia. Universities come to us with technologies and we work with them to mature them.
Prior to engaging with the TPT programme, we spent quite a considerable time, about 10 years, looking at desponding adhesives or ways to despond structural adhesives. And the reason we're having to do that is because these structural joints are highly cross-linked. Highly cross-linked because we want the strength and we want the durability, we want the crack resistance. And so that makes them very difficult to separate, and separate efficiently anyway.
The technology itself is a couple of different additives that can be included in off-the-shelf adhesives. These are then activated by an input of energy, whether that be heat or current, and they then expand, which causes joints to come apart, which means that you can disassemble structures that are otherwise permanent. We investigated 3 different heat sources. They were infrareds, induction, and also using a heat gun. The reason that we used those 3 different heat sources was to simulate a variety of different applications that the technology could be used in.
With the real big issues we have with climate change and resources and sustainability, we're really looking at applications for end of life. We really want to now look at not making things last as long as possible, but making them last as long as they need to. It's very broad in its range and applications. So you might want to put a temporary structure in place so that you can perform a certain task and then you have to take that away. You may want to refurbish the interior of an aircraft. Again, you could also, for instance, if you manufacture things incorrectly, put them in slightly the wrong place, you might be able to reposition them.
We need to make a shift from focusing on products that just last or are just really strong to products that, last and are strong, but also are resource efficient and more circular. And I think this is one of those projects that really draws on all of that. We are making it so that they have a secondary purpose and they can be disassembled or disbonded when we need them to. And that's the real key here, it's when we need them to. It's a very focused triggering system. That means that you don't compromise on the integrity of the component that you're making. You maintain that, but also there's this added bonus that you can disassemble it or despond it at end of life or repair it or whatever you need to do when it comes down to it.
There's lots of things you can do in a lab that will never translate through to an industrial application. And the TPT programme kind of helps us get that lab-based technology and see whether or not that can really make it through to a higher technology readiness level for then possibly being used in industry.
Oxford Brookes have come to us with something that's been proven at lab scale. We've now worked to put that into a medium scale demonstrator, and now with all the interest that we've received from our customers, we have the ability to really work with them to focus on their specific applications and see how we can tailor this technology for them.